Hello Legacy students, Marsh here. So today we're going to talk about the average rate of change. Some needs you're going to have for this video. You're going to want your notebook, pencil, and then the foldable that you received in class. Learning target for this particular video. I can describe a rate of change given a table, graph, or even in context form. So, just an introduction here. In 2008, about 66 million U.S. households had both a landline phones and cell phones. We want to describe the change. Ultimately, what we would want to determine is what is the average change per year, right? Well, ultimately, if you look at this problem here, you notice that you're probably going to notice it goes down each time, right? Well, what you are determining is a rate of change. You are noticing that there is a change in the y values and the x values. Rates of change can be found using this particular formula right here. Delta y over delta x. That's what this triangle means right here. This means delta. That's the word for it. Ultimately, what does delta mean? All it means is the difference. Okay? The difference of y's over the difference of x's. A rate of change. You've also seen a rate of change when you did lines and you talked about slope. Slope was a rate of change. So a rate of change is basically subtracting the y's over subtracting the x values. Now, we're going to be looking at a rate of change over an interval. An interval is a continuous portion of a function. Intervals, we can note them in various formats. So we can say x equals a number and x equals a number, knowing as the initial and the finals. Or we can use with brackets a comma b. Or we can use it as an inequality. The a is less than or equal to x, and which is less than or equal to b. Normally, we're going to see this form for an interval, or we might see this part too, with the x going to a number and to a number. Now, the rate of change of an interval is the average rate of change for that period. It's not necessarily going to be a constant rate of change. It depends what kind of graph / function you're looking at. So if we look how to calculate it, a rate of change, you're first going to want to identify the starting point of that interval. So what's the x and y coordinates of that starting point? Identify the ending point of the interval. Then you're going to want to determine the rate of change, so the delta y over delta x. So basically you want to determine what's the change in the y and what's the change in the x. All you're doing. Basically you're finding the difference of the y's over the difference of the x. Another way to look at it is the rise over the run. Okay? The result of your rate of change is the average rate of change. It does not mean it's the same every time. And then what we're going to do is interpret in the context of our problem. So let's flip back here to our start problem. So I want to describe the rate of change between the years of 2008 and 2011. So first thing I need to identify is my starting values. Well, they told me the start value of my interval is 2008. So it looks like the ordered pair for 2008 would be 66, right? Other end value of my interval is 2011. And it looks like 51 is the y value that relates to it. Now it tells me, my steps told me, I have identified those two. Now I need to find my rate of change. So I'm going to use delta y over delta x, or change of y over change of x. So changes in y, well, to find a change, basically you're just subtracting, right? If I want to find the difference or the change of it. So I'm going to subtract the two values. So 66 minus 51, that would be 15. This is 3. So it looks like I'm getting 5, right? For my average rate of change. So that means 5 would be the average rate. What does that mean in context of our problem? Well, that tells me that 5 million people on average per year are dropping their landline and cell phone coverage. So that means that 5 million people on average per year are dropping their landline and cell phone coverage. So they're either just going with the landline, but most likely they're probably going with cell phone, right? So 5 million people on average per year are dropping their landline or cell phone coverage. Now notice, guys, this is a linear example. So what you ultimately found was the slope of that line, right? But the thing that's cool about rate of change is you can find the rate of a change of something that is not linear. Let me repeat that. You can find the slope rate of change of something that's not linear. It's just not going to be a constant rate of change. It's going to be an average one. So I got a table here that represents the type of bacteria that doubles every 36 hours. In a petri dish, I put 12 of them to start out, and I let for 6 days. They want me to calculate and interpret the average rate of change over the interval of 2 to 5. So I'm going to flip to my next page here. So I'm doing 2 to 5. So I first want to identify my ordered pairs. Well, my initial value, my start part of my interval is 2 years. And on 2 days, wow. 2 goes to 30. So on 2 days, I now have 30 bacteria. And then 5 is my n value. That's 121. So they are determining that it'd be between those two. So now I got to find my rate of change between those two values. So let's set up our rate of change formula. So difference of y's, change in y, over the change of x. That numerator is going to turn into 121 minus 30, 91. Denominator will be 3. And 91 divided by 3, that does not come out nice. So we're going to, that would be our rate of change, but I'm going to write it as a decimal as well. So 30.3 repeating. So now, if I wanted to interpret this context and I wanted to give a reasoning, well, this means that there are 30.3 roughly bacteria being added per day on average. So this is telling me that 30.3 bacteria are being added per day on average, because when I divide that, it tells me that that is an average. Now notice how I'm saying average, guys. if I would take a different interval, I would get possibly a different rate of change because you are looking at a specific interval. Depending, if I would start from 0 to 6, you'd probably see that this would probably go down due to the fact you would have more time and it's a bigger spread of time. Okay? Let's try one more example. So they give me a graph here and they tell me what's the rate of change for the interval 1 to 3 and what's the interval of x equals 3 to x equals 6. So they're asking me about two intervals here. So 1 to 3, 1 comma, okay, 1. Oh, that looks like right here has a value of roughly, let's say, 550, right? 3 has a value of, let's go 1100. Okay, so now I want to find the average rate of that, right? So I'm going to find the difference of the y's and the difference of the x's, change in y's over change in x. So let's go 1100 minus 550. I get 550 over 2, which will simplify to 275. So my rate of change for that is 275 each step. Now notice, guys, that's an average rate of change. Let's try 3 to 6 now. So 3 we said was 3 comma 1100, and 6 years right here. Looks like it ends up right there. So that would be, we're counting by 2's, right? So this is 3200 up here. So 6 comma 3200. So if I'm going to do my quotient here, or not my quotient, but my ratio. So change in y's over my change in my x. Okay, let's subtract those y values, find the difference of them. I'm going to get 2100 divided by 3. I get 700. Notice that is a lot larger of an average rate of change. Now you're probably saying, well, why is that the case? Look at the graph, guys. Look how much steeper the curve starts to become at that particular point. This is a lot nicer of a curve, not as much growth. But from here to there, there's a lot of vertical growth. We are changing, the difference of the y values is very large. So which interval has a larger rate of change? This interval from 3 to 6. So I could either write it as x equals 3 to x equals 6, or I could write the interval like this, or I could write it like that, depending on which one I wanted to write. So, talking about rate of change, what do we know? Well, linear rate of change, you've talked about that before. You can choose any 2 points on a line and find a slope. And it's always going to be a constant rate of change. Non-linear rate of changes, they're a little different. You are told which 2 points to use, because if you are not told, you might not have the correct average rate of change. Your average could either get higher or lower. The rate of change is different at different intervals. Notice, different than linear. You're not going to get a constant rate of change, just like our last example. We didn't get the same rate of change for both sections of both intervals. We got different ones. However, they both use the same formula. You still are using change of y over change of x, the delta y over delta x. No difference in that form. You're still using basically what you used to call the slope formula. And with that, that's the end of this video. See you later, Sabers.